All right, cool. So what are we getting into today? We're getting into lesson 3 of Fast AI, practical deep learning for coders, right? All right, let's. Ooh. All right. Let's do this. We are on lesson 3. Your reading glasses. Okay. Where's this? Just want to make sure. Yes. Yeah, I have to. If I make it full screen, let's see. Yeah, part of it gets cut off on OBS, but maybe I can. Let me just readjust it. There we go. No, I know. I'm just changing the screen size. Okay. So I'm going to put us next to this guy. I don't remember his name. Anyway, all right. Let's do it. Yeah, we built a classifier for dogs, and we gave it pictures of Riggs to see what kind of breed he is. Oh, that's right. That's right. Mac or Linux or Windows. Right, right, right. So silly. Yep. Yes. Okay. Let me just. Oops. All right, we're gonna try that again. All right, hold on. Let me get the lesson up. Lesson 3. We did that, right? Mm-hmm. Right. Did we? Yeah, I don't remember what we used last time, to be honest. Mm-hmm. So what are you suggesting that if we used all of them, we would get what? Right. Mm-hmm. Yeah, yeah, yeah. Okay. Right. Yeah, let's keep watching and see what happens. Okay. So Martin, apparently they can't hear you. Yeah, seriously. I thought we fixed this. Nope. All right. I don't even know because you are coming in on OBS. No sound for Jeremy. Interesting. Yeah, apparently they can't hear. It's just me not saying anything, and everybody's just watching subtitles, just like you. Well, welcome to the stream, everybody. It sucks. Yeah. Let me see. Can you speak again, Martin? I'm just testing different audio tracks. Yeah. Very weird. Whoops. Yeah, could you just keep talking and then see if let me adjust this on. Could you read us a story? Yeah. Oops. Why is this? Okay, so I'm opening up another stream window. Is there a stream setting in OBS? Streaming. Yeah, everybody now can only just hear my voice and the sounds of Brooklyn. So, welcome, everyone. So, in this streaming, all right, I'm going to try something because I don't think I could change the OBS settings while streaming. So I think I need to stop streaming and then start streaming again. So unless somebody in the chat can help, knows how to do this a little differently. I don't know. Or not. Okay. All right, I'm just going to try that.
So I still don't know how I can have that. Okay, I guess I can have it muted and then I can see the stream. I still don't know how I can have that. Okay, I guess I can have chat with people if there's someone actually on there.
Okay, I think...
We're back.
I think the audio problems are fixed.
So let me see. When I say something now, does anything happen? Wait, I guess I could listen in myself, right? I don't really hear anything. You say something.
So say something.
Oh,
you can hear both. Awesome. Cool. All right. Really so everybody can.
You say something.
Yeah. All right.
Sweet.
Cool. Let's continue on that.
Hi, everyone.
Welcome back. Cool.
Okay.
All right, let's do it.
Thanks for letting us know that this wasn't working.
Yeah, awesome. Cool.
So we're like, for people who are just popped in here, we did we did lessons 1 to 3, like maybe 2 weeks ago. And now we're at lesson 3 and we built a couple of little projects and today we're just going through we're just listening to the lesson. Both Nick and I haven't seen it yet. So we're just going along and figuring out what he's talking about, basically.
Cool. Let's do it.
Right.
You don't have to use zeros. Zeros means pad it with black. You can also say like reflect to kind of have the pixels will kind of look a bit better that way if you use reflect. All of these different methods have their own problems. The pad method is kind of the cleanest. You end up with the correct size. You end up with all of the pixels. But you also end up with wasted pixels, so you kind of end up with wasted computation. The squish method is the most efficient because you get all of the information, and nothing's kind of wasted. But on the downside, your neural net's going to have to learn to kind of like recognize when something's been squished or stretched. And in some cases, it wouldn't even know. So if there's two objects you're trying to recognize, one of which tends to be thin and one of which tends to be thick, and otherwise they're the same, they could actually be impossible to distinguish. And then the default cropping approach actually removes some information. So in this case, this grizzly bear here, we actually lost a lot of its legs. So if figuring it out what kind of bear it was required looking at its feet, well, we don't have its feet anymore. So they all have downsides. So there's something else that you can do, a different approach, which is instead of to say resize, you can say random resized crop. And actually this is the most common approach. And what random resized crop does is each time it actually grabs a different part of the image and kind of zooms into it, right? So this is all the same image and we're just grabbing a batch of 4 different versions of it. And you can see some are kind of, they're all squished in different ways and we've kind of selected different subsets and so forth. Now, this kind of seems worse than any of the previous approaches because I'm losing information. Like this one here, I've actually lost a whole lot of its back, right? But the cool thing about this is that, remember, we want to avoid overfitting. And when you see a different part of the animal each time, it's much less likely to overfit because you're not seeing the same image on each epoch that you go around. That makes sense? So
pause.
So this random resized crop...
Is it... So he's reusing the same images a couple of times, or what? Like, is it like... or is it... Am I understanding this correctly? He's like taking slices of the image, but multiple times. So then like one image actually goes into the algorithm a couple of times, but different parts of it.
Right. Yeah. A resized a crop of like a window randomly throughout the original image, but just to keep the same 128 by 128.
But it's not just taking one of those windows per image, but it's doing it multiple times on each image, right?
Which is
it's another way of
transform
getting
amplifies.
more data. Like you make a couple of images out of one image.
I believe so. I believe it was multiple images, and that's. Do you want to back it up?
No, because this is a bunch of different things. This is like stretching it, so it's applying. It looks like it's applying all sorts of different things except for the cut, right? This is a stretch. This is a stretch in the other direction, and then it's different cuts.
Yeah. So the cool thing about this is that he's saying that, remember, we want to avoid overfitting. And when you see a different part of an animal each time, it's much less likely to overfit. So I think they're getting different parts of the image every single time, and then using
so like
that.
for each epoch, or what?
So it seems like, oh, what was that? It's not seeing the same image on each epoch that you go around. Yeah.
Okay, so every go around it takes a different cut and maybe even a stretch of the same image.
This one seems like it's not. I don't know what
Yeah,
random resized crop does, but he was saying that stretching is not super ideal, right?
But this looks like it's being stretched.
It does.
Am I
Yeah,
wrong?
it does.
So
I don't know. All right, let's keep going.
Okay.
Seeing the same image on each epoch that you go around. That makes sense? So, so this random resized crop approach is actually super popular. And so min scale 0.3 means we're going to pick at least 30% of the pixels of kind of the original size each time. And then we'll kind of like zoom into that square. So this idea of doing something so that each time the model sees the image, it looks a bit different to last time, it's called data augmentation. And this is one type of data augmentation. It's probably the most common, but there are others. One of the best ways to do data augmentation is to use this aug transforms function. And what aug transforms does is it actually returns a list of different augmentations. And so there are augmentations which change contrast, which change brightness, which warp the perspective. So you can see in this one here, it looks like this bit's much closer to you and this bit's much away from you because it's kind of been perspective warped. It rotates them. See, this one's actually been rotated. This one's been made really dark, right? These are batch transforms, not item transforms. The difference is that item transforms happen one image at a time. And so the thing that resizes them all to the same size, that has to be an item transform. Pop it all into a mini batch, put it on the GPU, and then a batch transform happens to a whole mini batch at a time. And by putting these as batch transforms, the augmentation happens super fast because it happens on the GPU. And I don't know if there's any other libraries as we speak, which allow you to write your own GPU accelerated transformations that run on the GPU in this way. So this is a super handy thing in FastAI too. So you can check out the documentation for aug transforms, and when you do, you'll find the documentation for all of the underlying transforms that it basically wraps, right? So you can see if I shift tab, I don't remember if I've shown you this trick before. If you go inside the parentheses of a function and hit shift tab a few times, it'll pop open a list of all of the arguments. And so you can basically see, you can say like, oh, can I sometimes flip it left, right? Can I sometimes flip it up, down? What's the maximum amount I can rotate, zoom, change the lighting, warp the perspective, and so forth.
How can we add different augmentations for train and validation sets?
So the cool thing is that automatically FastAI will avoid doing data augmentation on the validation set. So all of these aug transforms will only be applied to the training set. With the exception of random resized crop. Random resized crop has a different behavior for each. The behavior for the training set is what we just saw, which is to randomly pick a subset and kind of zoom into it. And the behavior for the validation set is just to grab the center, the largest center square that it can. You can write your own transformations.
Hey, I kind of
they're just Python. They're just standard
our
PyTorch
project
code.
The transform.
You want to try this out?
Yeah.
Okay. Let's do it.
Let's take a look with it. Do you have it around, or should I grab it?
Can you grab it and then send it in the chat?
Mhm. Or I guess I can, since we're not talking, I can also just share it here, right?
Sure. Yeah,
Since
you
it's
want
not
to share the
about-
screen?
Yeah, that makes sense. Okay, got it.
Okay, hold on.
And that was the product desktop images. Oh. What do you call that? So I'm still not entirely sure I understand what it does, but I think the changes get applied on one batch that goes, and one batch goes into one epoch. Is that how it is?
That's my understanding as well.
Okay. So wait, let's see. Where's? I guess I'm gonna have to connect. Connect to a hosted runtime. And make sure it's a GPU. Where's the runtime? This is where it is.
Nice. It's a GPU.
Save. Unable to connect. You connected? Yes. Okay. Let's see. What are we gonna have to run again from this? Let me reorient what we have here. So we got our sample data. No, this is something else. Content. Sample data.
No.
Bin. Where's this? Let's see whether it runs it. Okay, this is a little more complicated than I thought. We have that on the...
We had the same issue last time. I think it was like a different, like this production desktop is saved somewhere else. Like this notebook, I think, was saved somewhere else. Right?
This is ours, though. This is not the one from FastAI. This is the copy that we made, that we worked on. Like I called it production desktops, because it's where we do the desktop image classification. So, from my understanding, it should be somewhere here in the files. But I guess I should have cleaned up this note. Shame on me. What is that even about?
I don't know. Do you want to just open up another one
WJSON?
from?
What was that? What did they do there? Maybe this is just a weird leftover first cell that I forgot to delete or something like that.
Probably.
Let's see. But we still need to have the data somewhere in there, right? Like we were downloading all this. We're downloading all these images, these desktop backgrounds.
Yeah.
And then download images. Oh God. No, we didn't end up doing it like that though, right?
No, we That's what I think. This is a different.
Okay, you know.
This is from a different thing.
Is it the search images?
Oh, Windows desktop backgrounds. Maybe this is the one that we we did
You
last
got a
week.
different one?
No. I see Windows desktop backgrounds on the
Yeah.
the
That was our
results and
search
stuff.
key.
That was what we were searching. No, the only one that I have was when we did the dog breed classification for regs. That's what I have on mine.
It's still there.
Yeah.
I mean, the
So
outputs
what
are
are
still there.
what are you trying to do right now?
I wanted to run the data augmentation that he's doing on our desktop image classifier to see whether it whether it improves the classification that we had.
Oh, from last week or 2 weeks ago. Can you run all the cells and see if it still works? It should, right? I guess it shouldn't have to download all the images again. We
Where is
did all
that?
that.
Yeah, I just don't know where they are. I'll run. Oh, let's see. Oh, now it's gonna do the thing.
It's gonna
again,
do the JSON thing on the beginning.
which means it breaks, I think, right?
Yeah.
This is what is this even? Go away.
Get out of here. We don't want you here. Yeah.
Right. So this starting from here. And then runtime, run all below. Can
Run
we do
after.
that? Run after. So here it's connecting to my drive. Is that what we set up? So drive, my drive. Is that where it is? Current working directory. So it's running from. I really haven't figured out this file system here yet.
Yeah.
Drive, my drive data. Maybe we had to mount this or something. See, because it's still not finding it. I love this little search Stack Overflow button. Content.
Oh,
Google Drive. My drive.
there we
it is.
go.
So, collab data.
So content.
Data. And there we got the.
Yeah. Oh, okay. There we go. Awesome. So it's
content.
so current working directory is
Did they change
content. Or no? I guess is it?
this? My drive. Data. Let me try that. Maybe they changed something. And it
Are
used
you
to be
working
called
inside
drive.
of content, or are you in like root?
Let's see. Bam.
There we go.
Look at that. So it looks like since we
Somebody
did this,
changed it.
they changed the name of that.
So silly.
Holy crap. Okay. Run
After.
After, thank you. Okay. Drive.
Now it's getting
Now it's called
renamed to
drive,
drive.
again. I'm very confused.
I guess we rename it somewhere,
Why would we do
or
that?
maybe
That sounds like a bad idea.
I don't know. Do you want to just start from the beginning and just change G drive back to drive and see if that works?
I really need to clean up this notebook.
This is so silly.
Why is this happening? At least I'm gonna learn that it's run after.
Yeah.
Okay, last try. If that doesn't work, I'm gonna dedicate to cleaning up this notebook, and then we try it after I've done that.
Fair enough.
It might also be that our API key isn't valid anymore.
Mm-hmm.
Right, like maybe that's why this is breaking here. Let me see. Operation returned an invalid status code, permission denied. So I guess probably the API key had like it's like the 7-day, right? It has this 7-day, you can use it for 7 days or something.
Didn't you just get a new API key? Oh no, this is for Bing.
I didn't.
This is the whole Microsoft thing that we had to do last time.
We had to go through this whole thing. Content URL. Which means that now we don't have the images.
Right. You want to just quickly do that?
So it's not going to work. What?
Do you want to quickly do that, or do you want to just get back to the video?
Well, we still have the wallpapers here, right? Like we downloaded them last time, so I don't actually need to do this.
Oh, that's true. And we did, yeah.
So I can just start here. If not path exists, make directory. Make them. I think we got those. Wait, are they split up in folders?
It's just wallpaper. We had more wallpapers than that.
Did.
What else is in there? Oh, just a bunch of other stuff, yeah.
And then download images destination, content URL. These ones are not going to work because I guess we didn't save the URL files. Dear God. Okay, anyways, I'm gonna host systems.
Yeah,
Okay,
where
it's
something's
not-
happening. Yeah,
This is
permission
this
denied.
is too messy. I am shocked.
Yeah, this is getting a little messy.
This is too messy. I'm gonna abandon ship.
Yeah. You want to go back to the
Yeah.
video?
No, I don't really want to be honest, but like now I want to clean this up, but
Yeah. Well, we'll clean it up and do.
that's not. Yeah, I hand back the power to you, sir.
Okay. Just so
After
that
my failed attempt
you can also see.
of seizing power.
Okay. You see my screen, right?
Yes.
All right.
Hit it.
The way if you and by default it will only be applied to the training set. If you want to do something fancy like random resize crop where you actually have different things being applied to each, you should come back to the next course to find out how to do that or read the documentation. It's not rocket science, but it's not something most people need to do. Okay, so last time we here did bears.new with a random resize crop, min scale of 0.5. We added some transforms. And we went ahead and trained. Actually, since last week, I've rerun this notebook. It's on a different computer and I've got different images, so it's not all exactly the same. But I still got a good confusion matrix. So of the black bears, 37 were classified correctly, 2 were grizzlies, 1 was a teddy. Now, and we talked about plot top losses. And it's interesting, you can see in this case, there's some clearly kind of odd things going on. This is not a bear at all. This looks like it's a drawing of a bear, which is decided is predicted as a teddy, but this thing's it's meant to be a drawing of a black bear. I can certainly see the confusion. You can see how some parts of it are being cut off. We'll talk about how to deal with that later. Now, one of the interesting things is that we didn't really do much data cleaning at all before we built this model. The only data cleaning we did was just to validate that each image can be opened. There was that verify images call. And the reason for that is it's actually much easier normally to clean your data after you create a model. And I'll show you how. We've got this thing called image classifier cleaner, where you can pick a category, right? And training set or validation set. And then what it will do is it will then list all of the images in that set, and it will pick the ones which which is the least confident about, which is the most likely to be wrong, where the loss is the worst, to be more precise. And so this is a great way to look through your data and find problems. So in this case, the first one is not a teddy or a brown bear or a black bear, it's a puppy dog, right? So this is a great cleaner because what I can do is I can now click delete here. This one here looks a bit like an Ewok rather than a teddy. I'm not sure. What do you think, Rachel? Is it an Ewok? I'm going to call it an Ewok, right? And so you can kind of go through, okay, that's definitely not a teddy.
We did this last time, right?
And so you can either say like, oh, that's wrong, that's actually a grizzly bear. Or it's wrong, it's a black bear, or I should delete it, or by default just keep it, right? And you can kind of keep going through until you think like, okay, they all seem to be fine. Maybe that one's not. And kind of once you get to the point where they all seem to be fine, you can kind of say, okay, probably all the rest are fine too, because they all have lower losses, so they all fit the kind of the mold of a teddy. And so then I can run this code here, where I just go through cleaner.delete. So that's all the things which I select to delete for, and unlink them. So unlink is just another way of saying delete a file. That's the Python name. And then go through all the ones that we said change, and we can actually move them to the correct directory. If you haven't seen this before, you might be surprised that we've kind of created our own little GUI inside Jupyter Notebook. Yeah, you can do this, and we built this with less than a screen of code. You can check out the source code in the FastAI notebooks. So this is a great time to remind you that...
Can you pause for a second? Oops.
Yep.
And we also learned that you have to run it after you do one selection before changing to a different label, because otherwise it deletes everything. Remember, if you go like back, just can you click back twice?
Yeah.
To that last image.
Oh my goodness. This player is like...
This is a great time to remind you that...
super annoying.
Like, remember when we were doing...
AI.
Like, so where he has Teddy selected, Teddy and train. If you change any of these ones, then it removes the ones that you have classified out of it. So you can't change these drop downs. You got to run the code first, like delete or clean and change, and then you can change it.
Yeah. That
was all.
Notebooks. So this is a great time to remind you that FastAI is built with notebooks. And so if you go to the FastAI repo and clone it, and then go to NBs, you'll find all of the code of FastAI written as notebooks. Weird. And they've got a lot of pros and examples and tests and so forth. So the best place to learn about how this is implemented is to look at the notebooks rather than looking at the module code. Okay. By the way, sometimes you'll see like weird little comments like this. These weird little comments are part of a development environment for Jupyter Notebook we use called NBDev, which we built. So Silva and I built this thing to make it much easier for us to kind of create books and websites and libraries in Jupyter Notebooks. So this particular one here, hide, means when this is turned into a book or into documentation, don't show this cell. And the reason for that is because you can see I've actually got it in the text, right? But I thought when you're actually running it, it would be nice to have it sitting here waiting for you to run directly. So that's why it's shown in the notebook, but not in the book. It's shown differently. And you'll also see these things like S: with a quote. In the book, that would end up saying Sylvain says, and then what he says. So there's kind of little bits and pieces in the in the notebooks that just look a little bit odd, and that's because it's designed that way in order to show, in order to create stuff in the book. Right. So then last week we saw how you can export that to a pickle file that contains all the information for the model. And then on the server where you're going to actually do your inference, you can then load that saved file and you'll get back a learner that you can call predict on. So predict perhaps the most interesting part of predict is the third thing that it returns, which is a tensor, in this case containing 3 numbers. The 3 numbers, there's 3 of them because we have 3 classes: teddy bear, grizzly bear, and black bear, right? And so this doesn't make any sense until you know what the order of the classes is, kind of in your data loaders. And you can ask the data loaders what the order is by asking for its vocab. So a vocab in FastAI is a really common concept. It's basically any time that you've got like a mapping from numbers to strings or discrete levels, the mapping is always stored in the vocab. So here, this shows us that the activation for black bear is 10e neg 6. The activation for grizzly is 1. And the activation for teddy is 10e neg 6. So very, very confident that this particular one, it was a grizzly. Not surprisingly, this was something called grizzly.jpg. So you need to kind of know this mapping in order to display the correct thing. But of course, the data loaders object already knows that mapping, and it's all the vocab, and it's stored in with the loader. So that's how it knows to say grizzly automatically. So the first thing it gives you is the human readable string that you'd want to display. So this is kind of nice that with FastAI 2, you save this object, which has everything you need for inference. It's got all the information about normalization, about any kind of transformation steps, about what the vocab is, so it can display everything correctly. Right. So now we want to deploy this as an app. Now, if you've done some web programming before, then all you need to know is that this line of code and this line of code, so this is the line of code you would call once when your application starts up, and then this is the line of code you would call every time you want to do an inference. And there's also a batch version of it, which you can look up if you're interested. This is just to do one at a time. So there's nothing special if you're already a web programmer or have access to a web programmer. These are, you just have to stick these 2 lines of code somewhere, and the 3 things you get back are the human readable string, if you're doing categorization, the index of that, which in this case is 1, is grizzly, and the probability of each class. One of the things we really wanted to do in this course, though, is not assume that everybody is a web developer. Most data scientists aren't. But gee, wouldn't it be great if all data scientists could at least like prototype an application to show off the thing they're working on? And so we've tried to kind of curate an approach, which none of it's stuff we've built, it's really just curated, which shows how you can create a GUI and create a complete application in Jupyter Notebook. So the key pieces of technology we use to do this are IPython widgets, which is always called IPyWidgets, and voila. IPyWidgets, which we import by default as widgets, and that's also what they use in their own documentation, has GUI widgets. For example, a file upload button. So if I create this file upload button and then display it, I see, and we saw this in the last lesson as well, or maybe it was lesson 1, an actual clickable button. So I can go ahead and click it, and it says now, okay, you've selected one thing. So how do I use that? Well, these widgets have all kinds of methods and properties, and the upload button has a data property, which is an array containing all of the images you uploaded. So you can pass that to pil image.create. And so .create is kind of the standard factory method we use in FastAI to create items. And pil image.create is smart enough to be able to create an item from all kinds of different things. And one of the things it can create it from is a binary blob, which is what a file upload contains. So then we can display it, and there's our teddy, right? So you can see how, cells of Jupyter Notebook can refer to other cells that were created, that were kind of have GUI created data in them. So let's hide that teddy away for a moment. And the next thing to know about is that there's a kind of widget called output. And an output widget is, it's basically something that you can fill in later, right? So if I delete, actually, this part here. So I've now got an output widget. Yeah, actually, let's do it this way around. And you can't see the output widget, even though I said please display it, because nothing is output. So then in the next cell, I can say with that output placeholder, display a thumbnail of the image, and you'll see that the display will not appear here. It appears back here, right? Because that's where the placeholder was. So let's run that again to clear out that placeholder. So we can create another kind of placeholder, which is a label. The label's kind of a something where you can put text in it. So you can give it a value, like, I don't know, please choose an image. Okay, so we've now got a label containing please choose an image. Let's create another button to do a classification.
Just quick, Martin, do we have to do anything to the current notebook to show any of this stuff? Is this a different one that they're working in?
Wait, say again. I'm not interested.
Is this a different notebook that they're working in, or did we? Because it still says O2 production.
Yeah, it's the same one. Like, I think
one?
It follows just a little later on. And maybe if our pickle file is still somewhere around, I'm so confused about this drive. Like the file system there. But
yeah.
I do have the O systems folder now again, and there's a Windows, because I know we saved the pickle file somewhere, but I think we also put it on GitHub, didn't we?
I don't remember. If you want to just check. Also, are you opposed to speeding this up to 1.5?
Oh, not at all.
Not at all, right? Wonderful.
Okay, yeah, I
Maybe
can
you
check
speed it
that.
up to 2 later.
My problem is I can't really do anything on the side because I got to read this stuff to follow along.
Oh, that's
Otherwise I
right.
could go,
Yeah. For the next one, we got to figure out how to have you listen in on this as well.
Yeah, that would be nice. Then I can search a little around, clean up the notebook or something.
Exactly.
Or find out whether we have the pickle file still on our GitHub.
Sure. All right. I'm going to start playing this again.
Yes.
Now, this is not a file upload button, it's just a general button. So this button doesn't do anything, right? It doesn't do anything until we attach an event handler to it. An event handler is a callback. We'll be learning all about callbacks in this course. If you've ever done any GUI programming before, or even web programming, you'll be familiar with the idea that you write a function, which is the thing you want to be called when the button is clicked on, and then somehow you tell your framework that this is the on-click event. So here I go, here's my button run. I say the on-click event, the button run is, we call this code. And this code is going to do all the stuff we just saw. It's going to create an image from the upload. It's going to clear the output, display the image, call predict, and then replace the label with a prediction. So there it all is. Now, so that hasn't done anything, but I can now go back to this classify button, which now has an event handler attached to it. So watch this. Click. Boom. And look, that's been filled in. That's been filled in. Right? In case you missed it, let's run these again to clear everything out. Okay, everything's gone. This is please choose an image. There's nothing here. I click classify. Pop, pop, pop. Right? So it's kind of amazing how our notebook has suddenly turned into this interactive prototyping playground for building applications. And so once all this works, we can dump it all together. And so the easiest way to dump things together is to create a VBox. A VBox is a vertical box, and it's just something that you put widgets in. And so in this case, we're going to put the following widgets. We're going to have a label that says select your bear, then an upload button, a run button, an output placeholder, and a label for predictions. So let's run these again just to clear everything out, so that we're not cheating. And let's create our VBox. So as you can see, it's just got all the pieces, right? Now we've got, what about, oh, I accidentally ran the thing that displayed the bear. Let's get rid of that. Okay, so there it is. So now I can click upload. I can choose my bear. Okay, and then I can click classify. Right? And notice this is exactly this is like the same buttons as these buttons. They're like two places we're viewing the same button, which is kind of a wild idea. So if I click classify, it's going to change this label and this label, because they're actually both references to the same label. Look, there we are. Okay, so this is our app, right? And so this is actually how I built that image cleaner GUI. Is just using these exact things. And I built that image cleaner GUI cell by cell in a notebook, just like this. And so you get this kind of interactive experimental framework for building a GUI. So if you're a data scientist who's never done GUI stuff before, this is a great time to get started, because now you can make actual programs. Now, of course, an actual program running inside a notebook is kind of cool, but what we really want is this program to run in a place anybody can run it. That's where Voila comes in. So Voila needs to be installed. So you can just run these lines to install it. It's listed in the pros. And what Voila does is it takes a notebook and just doesn't display anything except for the markdown, the IPython widgets, and the outputs. Right? So all the code cells disappear, and it doesn't give the person looking at that page the ability to run their own code. They can only interact with the widgets. Right? So what I did was I copied and pasted that code from the notebook into a separate notebook which only has those lines of code. Right? So so these are just the same lines of code that we saw before.
What do you mean?
And so this is a notebook. It's just a normal notebook.
What was that?
You said you were meaning something. I was just wondering what you were meaning to.
Oh, just Jeremy and his wisdom.
Oh, just Jeremy.
Then I installed Voila. And then when you do that, if you navigate to this notebook, but you replace notebooks up here with Voila, it actually displays not the notebook, but just, as I said, the markdown and the widgets. So here I've got my bear classifier, and I can click upload. Let's do a grizzly bear this time. And this is a slightly different version. I actually made this so there's no classify button. I just thought it would be a bit more fancy to make it so when you click upload, it just runs everything. But as you can see, there it all is, right? It's all working. So this is the world's simplest prototype, but it's a proof of concept, right? So you can add widgets with drop downs and sliders and charts and everything that you can have in a an Angular app or a React app or whatever. And in fact, there's even stuff which lets you use, for example, the whole Vue.js framework. If you know that, it's a very popular JavaScript framework. The whole Vue.js framework, you can actually use it in widgets, and voila. So now we want to get it so that this app can be run by someone out there in the world. So the Voila documentation shows a few ways to do that.
So that's
but
cool.
perhaps the easiest one
on Friday we can
is
actually make an app from our desktop classifier and put it up like that.
Yeah,
I'm excited about that.
Yeah. I think just put it live, create an API where people can just submit their wallpapers.
Well, or
and
just
then we
with
can
the button in the way that he set it up, that they can just click it and upload it.
Yeah, but we can do more magic than that.
That's true. We could actually build something.
We could actually build something. And it's just the three of us, you, myself, and our machine opinion on whether this is a Windows desktop, a Mac desktop, or a Linux desktop. All right.
And so Binder is at mybinder.org. And all you do is you paste in your GitHub repository name here, right? And this is all in the book, right? So you paste in your GitHub repo name. You change where it says file. You change that to URL. You can see. And then you put in the path, which we were just experimenting with, right? So you pop that here. And then you say launch. And what that does is it then gives you a URL. So then this URL you can pass on to people. And this is actually your interactive running application. So bind is free. And so this is, anybody can now use this to take their Voila app and make it a publicly available web application. So try it. As it mentions here, the first time you do this, Binder takes about 5 minutes to build your site, because it actually uses something called Docker to deploy the whole FastAI framework and Python and blah, blah, blah. But once you've done that, that virtual machine will keep running for, as long as people are using it, it'll keep running for a while. That virtual machine will keep running for a while as long as people are using it, and it's reasonably fast. So a few things to note here. Being a free service, you won't be surprised to hear this is not using a GPU; it's using a CPU. And so that might be surprising that we're deploying to something which runs on a CPU. When you think about it, though, this makes much more sense to deploy to a CPU than a GPU. Just a moment. The thing that's happening here is that I am passing along. Let's go back.
Would you even need a? Is that what he's saying? That you don't really need a GPU for doing the classification, right? Once you have the model, it's just for training the model.
Yeah, essentially, yeah.
I'm passing along a single image at a time. So when I pass along that single image, I don't have a huge amount of parallel work for a GPU to do. This is actually something that a CPU is going to be doing more efficiently. So we found that for folks coming through this course, the vast majority of the time, they wanted to deploy inference on a CPU, not a GPU, because they're normally just doing one item at a time. It's way cheaper and easier to deploy to a CPU. And the reason for that is that you can just use any hosting service you like, because just remember, this is just a program at this point, right? And you can use all the usual horizontal scaling, vertical scaling. You can use Heroku, you can use AWS, you can use inexpensive instances, super cheap and super easy. Having said that, there are times you might need to deploy to a GPU. For example, maybe you're processing videos, and so like a single video on a CPU to process it might take all day. Or you might be so successful that you have 1,000 requests per second. In which case you could take 128 at a time, batch them together, and put the whole batch on the GPU and get the results back and pass them back around. And you've got to be careful of that, right? Because if your requests aren't coming fast enough, your user has to wait for a whole batch of people to be ready to be processed. But conceptually, as long as your site is popular enough, that could work. The other thing to talk about is you might want to deploy to a mobile phone. And deploying to a mobile phone, our recommendation is wherever possible, do that by actually deploying to a server and then have a mobile phone talk to the server over a network. Because if you do that, again, you can just use a normal PyTorch program on a normal server and normal network calls. It makes life super easy. When you try to run a PyTorch app on a phone, you're suddenly now not in an environment where like PyTorch will run natively, and so you have to convert your program into some other form. And there are other forms, and the main form that you convert it to is something called ONNX, which is specifically designed for kind of super high speed, high performance approach that can run on both servers or on mobile phones. It does not require the whole Python and PyTorch kind of runtime in place. But it's much more complex and not easy. It's harder to debug, it's harder to set it up, it's harder to maintain it. So if possible, keep things simple. And if you're lucky enough that you're so successful that you need to scale it up to GPUs and stuff like that, then great. Hopefully you've got the finances at that point to justify spending money on a ONNX expert or serving expert or whatever. And there are various systems you can use to ONNX runtime and AWS SageMaker, where you can kind of say, here's my ONNX bundle, and it'll serve it for you or whatever. PyTorch also has a mobile framework, same idea. So, all right, so you've got, it's kind of funny, we're talking about two different kinds of deployment here. One is deploying like a hobby application, that you're prototyping, showing off to your friends, explaining to your colleagues how something might work, a little interactive analysis. That's one thing. Or but maybe you're actually prototyping something that you want to turn into a real product, or an actual real part of your company's operations. When you're deploying, something in real life, there's all kinds of things you have to be careful of. One example of something to be careful of is, let's say you did exactly what we just did, which actually, this is your homework, is to create your own application. Right? I want you to create your own image search application. You can use my exact set of widgets and whatever if you want to. But better still, go to the iPy-widgets website and see what other widgets they have and try and come up with something cool. Try and show off as best as you can and show us on the forum. Now, let's say you decided that you want to create an app that would help the users of your app decide if they have healthy skin or unhealthy skin. So if you did the exact thing we just did, rather than searching for grizzly bear and teddy bear and so forth on Bing, you would search for healthy skin and unhealthy skin. Right? So here's what happens, right? And remember, in our version, we never actually looked at Bing. We just used the Bing API, the image search API. But behind the scenes, it's just using the website. Right? So if I type healthy skin and say search, I actually discover that the definition of healthy skin is young white women touching their face lovingly. So that's what your healthy skin classifier would learn to detect, right? And so this is a great example from Deb Raji, and you should check out her paper, Actionable Auditing. Got lots of cool insights about model bias. But I mean, here's like a fascinating example of how if you weren't looking at your data carefully, you end up with something that doesn't at all actually solve the problem you want to solve. This is tricky, right? Because the data that you train your algorithm on, if you're building like a new product that didn't exist before, by definition, you don't have examples of the kind of data that's going to be used in your life, right? So you kind of try to find some from somewhere. And if you do that through like a Google search, it's pretty likely you're not going to end up with a set of data that actually reflects the kind of mix you would see in real life. The main thing here is to be careful, right? And in particular for your test set, that final set that you check on, really try hard to gather data that reflects the real world. So like just, for example, the healthy skin example, you might go and actually talk to a dermatologist and try and find like 10 examples of healthy and unhealthy skin or something. And that would be your kind of gold standard test.
So just to that point, maybe we shouldn't have trusted Bing to give us Windows and Linux desktop images.
Yeah.
Maybe we should have made like a poll of like, hey, are you a Mac user? Are you a Windows user? What's your desktop image?
Right.
And just get a bunch of photos of like people's grandkids. And then it would just be very confusing.
There's all kinds of issues you have to think about in deployment. I can't cover all of them. I can tell you that this O'Reilly book called Building Machine Learning Powered Applications is a great resource. And this is one of the reasons we don't go into detail about A/B testing and when should we refresh our data and how we monitor things and so forth, is because that book's already been written, so we don't want to rewrite it. I do want to mention a particular area that I care a lot about, though, which is, let's take this example. Let's say you're rolling out this bear detection system, and it's going to be attached to video cameras around a campsite. It's going to warn campers of incoming bears. So if we used a model that was trained with that data that we just looked at, those are all very nicely taken pictures of pretty perfect bears, right? There's really no relationship to the kinds of pictures you're actually going to have to be dealing with in your campsite bear detector, which is going to have video, not images. It's going to be nighttime. It's going to be probably low resolution security cameras. You need to make sure that the performance of the system is fast enough to tell you about it before the bear kills you. There will be bears that are partially obscured by bushes or in lots of shadow or whatever, none of which are the kinds of things you would see normally in like internet pictures. So what we call this out-of-domain data. Out-of-domain data refers to a situation where the data that you are trying to do inference on is in some way different to the kind of data that you trained with. And this is actually, there's no perfect way to answer this question. And when we look at ethics, we'll talk about some really helpful ways to minimize how much this happens. For example, it turns out that having a diverse team is a great way to kind of avoid being surprised by the kinds of data that people end up coming up with. But really, it's just something you've got to be super thoughtful
around
about.
for a second. You can catch me up.
Very similar to that is something called domain shift. And
What was that? I don't know where Martin is going. We maybe start. Okay. All right, we're just going to keep playing the video, and we'll catch him up when he gets back.
Shift is where maybe you start out with all of your data is in domain data, but over time, the kinds of data that you're seeing changes. And so over time, maybe raccoons start invading your campsite, and you weren't training on raccoons before it was just a bear detector. And so that's called domain shift, and that's another thing that you have to be very careful of. Rachel, what's your question?
No, I was just going to add to that in saying that all data is biased, so there's not kind of a form of debiased data or perfectly representative in all cases data, and that a lot of the proposals around addressing this have kind of been converging to this idea that you see in papers like Tim McEbru's data sheets for data sets of just writing down a lot of the details about your data set and how it was gathered and in which situations it's appropriate to use and how it was maintained. And so that's not totally eliminated bias, but that you're just very aware of the attributes of your data set so that you won't be blindsided by them later. And there have been kind of several proposals in that school of thought, which I really like around this idea of just kind of understanding how your data was gathered and what its limitations are.
Thanks, Rachel. So a key problem here is that you can't know the entire behavior of your neural network. With normal programming, you typed in the if statements and the loops and whatever, so in theory you know what the hell it does, although it's still sometimes surprising. In this case, you didn't tell it anything, you just gave it examples to learn from and hoped that it learned something useful. There are hundreds of millions of parameters in all of these neural networks, and so there's no way you can understand how they all combine with each other to create complex behavior. So really, there's a natural compromise here, is that we're trying to get sophisticated behavior, so it's like recognizing pictures, sophisticated enough behavior we can't describe it. And so the natural downside is you can't expect the process that the thing is using to do that to be describable for you to be able to understand it. So our recommendation for kind of dealing with these issues is a very careful deployment strategy, which I've summarized in this little graph, this little chart here. The idea would be, first of all, whatever it is that you're going to use the model for, start out by doing it manually. So have a park ranger watching for bears. Have the model running next to them, and each time the park ranger sees a bear, they can check the model and see, did it seem to pick it up? So the model's not doing anything. There's just a person who's running it and seeing would have made sensible choices. And once you're confident that it makes sense, that what it's doing seems reasonable, it's in as close to the real life situation as possible, then deploy it in a time and geography limited way. So pick one campsite, not the entirety of California, and do it for 1 day, and have somebody watching it super carefully, right? So now the basic bear detection is being done by the bear detector, but there's still somebody watching it pretty closely, and it's only happening in 1 campsite for 1 day. And so then, as you say, okay, we haven't destroyed our company yet, but let's do 2 campsites for a week, and then let's do the entirety of Marin for a month, and so forth. So this is actually what we did when I used to this company called Optimal Decisions. Optimal Decisions was a company that I founded to do insurance pricing. And if you change insurance prices by a percent or two in the wrong direction, the wrong way, you can basically destroy the whole company. This has happened many times. Insurers are companies that set prices. That's basically the product that they provide. So when we deployed new prices for Optimal Decisions, we always did it by saying okay, we're going to do it for 5 minutes for everybody whose name ends with a D. So we kind of try to find some group which hopefully would be fairly, it'll be different, but not too many of them. And we'd gradually scale it up, and you've got to make sure that when you're doing this, that you have a lot of really good reporting systems in place that you can recognize, are your customers yelling at you? Are your computers burning up? Are are your computers burning up? Are your costs spiraling out of control, and so forth. So it really requires great reporting systems.
Does Fast AI have methods built in that provide for incremental learning, i.e. improving the model slowly over time with a single data point each time?
Yeah, that's a great question. So this is a little bit different, which is this is really about dealing with domain shift and similar issues by continuing to train your model as you do inference. And so the good news is you don't need anything special for that. It's basically just a transfer learning problem. So you can do this in many different ways. Probably the easiest is just to say, like, okay, each night, at midnight, we're going to set off a task which grabs all of the previous day's transactions as mini batches and trains another epoch. And so, yeah, that actually works fine. You can basically think of this as a fine-tuning approach where your pre-trained model is yesterday's model and your fine-tuning data is today's data. So as you roll out your model, one thing to be thinking about super carefully is that it might change the behavior of the system that it's a part of. And this can create something called a feedback loop. And feedback loops are one of the most challenging.
Welcome back.
Thank you. So recap what happened.
Oof. Recap. Okay, so he was just talking about domain shift of how, and then just making sure that the images that you're using or whatever you're using doesn't have a ton of bias, and also just checking in with, like, reiterating that
what's
check.
Domain shift? Sorry.
So
domain shift.
yeah. So domain shift. Here, he had it up before.
Yep. Sum it up in your own words.
So the idea was that data changes throughout time, and then you want to just retrain your model on that new data. That was the gist of what I got from domain shift. And then he went about talking how you would deploy this bear classifier at campsites, which I thought was kind of interesting, and have like a park ranger go and be like, yep, that's a black bear, that's a grizzly bear, someone who has domain experience. And then he went off on saying that maybe you should just put this in a single campsite. And at that point, my mind went off and thought about, well, what if you just had the campers, the panicking campers, go up to this system and be like, yes, that is definitely a grizzly bear. No, this is not a teddy bear. Yeah. Yes, this is a black bear.
Panicking campers are usually the best source of information, I think.
Well, it would be interesting to like train a separate model of this is the park ranger's perspective, and these are the panicking campers. I thought that'd be kind of interesting.
Yeah.
Anyway, all right, let's go.
You can make a GAN and the fights between the two. Oh, sorry.
Right, and then just see like how many times the panicking camper model will misclassify a teddy bear.
Right.
But then we also have to go to these campsites and place teddy bears in the bushes and make rattling noises and try to, this is too much work. Anyway.
Pricing. And if you change insurance prices by, a percent or two in the wrong direction, the wrong way, you can basically destroy the whole company. This has happened many times. Insurers are companies that set prices. That's basically the product that they provide. So when we deploy new prices for optimal decisions, we always did it by saying okay, we're going to do it for 5 minutes, or everybody whose name ends with a D. So we kind of try to find some group which hopefully would be fairly, it'll be different, but not too many of them. And we're gradually scaled up, and you've got to make sure that when you're doing this, that you have a lot of really good reporting systems in place that you can recognize, are your customers yelling at you? Are your computers burning up? Are your computers burning up? Are your costs spiraling out of control, and so forth. So it really requires great reporting systems.
Does Fast AI have methods built in that provide for incremental learning, i.e. improving the model slowly over time with a single data point each time?
Yeah, that's a great question. So this is a little bit different, which is this is really about dealing with domain shift and similar issues by continuing to train your model as you do inference. And so the good news is you don't need anything special for that. It's basically just a transfer learning problem. So you can do this in many different ways. Probably the easiest is just to say each night, at midnight, we're going to set off a task which grabs all of the previous day's transactions as mini batches and trains another epoch. And so, yeah, that actually works fine. You can basically think of this as a fine-tuning approach where your pre-trained model is yesterday's model and your fine-tuning data is today's data. So as you roll out your model, one thing to be thinking about super carefully is that it might change the behavior of the system that it's a part of. And this can create something called a feedback loop. And feedback loops are one of the most challenging things for real-world model deployment, particularly machine learning models, because they can take a very minor issue and explode it into a really big issue. So, for example, think about a predictive policing algorithm. It's an algorithm that was trained to recognize, basically trained on data that says whereabouts arrests are being made. And then as you train that algorithm based on where arrests are being made, then you put in place a system that sends police officers to places that the model says are likely to have crime, which in this case where were arrests. But then more police go to that place, find more crime, because the more police that are there, the more they'll see. They arrest more people, causing, and then if you do this incremental learning, like we're just talking about, then it's going to say, oh, there's actually even more crime here, and so tomorrow it sends even more police. And so in that situation, you end up like, the predictive policing algorithm ends up going to send all of your police for one street block, because at that point, all of the arrests are happening there, because that's the only place you have policemen, right? I should say police officers. So there's actually a paper about this issue called To Protect and Serve. And in To Protect and Serve, the authors write this really nice phrase. Predictive policing is aptly named. It is predicting policing, not predicting crime. So if the initial model was perfect, whatever the hell that even means, but like it somehow sent police to exactly the best places to find crime based on the probability of crimes actually being in place, I guess there's no problem, right? But as soon as there's any amount of bias, right? So for example, in the US, there's a lot more arrests of black people than of white people, even for crimes where black people and white people are known to do them the same amount. So in the presence of this bias, or any kind of bias, you're kind of like setting off this domino chain of feedback loops where that bias will be exploded over time. So one thing I like to think about is to think like, well, what would happen if this model was just really, really, really good? So like, who would be impacted? What would this extreme result look like? How would you know what was really happening? This incredibly predictive algorithm that was like changing the behavior of your police officers or whatever. What would that look like? What would actually happen? And then like think about like, okay, what could go wrong? And then what kind of rollout plan, what kind of monitoring systems, what kind of oversight could provide the circuit breaker? Because that's what we really need here, right? Is we need, like nothing's going to be perfect. You can't be sure that there's no feedback loops. But what you can do is try to be sure that you see when the behavior of your system is behaving in a way that's not what you want. Did you have anything to add to that, Rachel?
All I would add to that is that you're at risk of potentially having a feedback loop anytime that your model is kind of controlling what your next round of data looks like. And I think that's true for pretty much all products. And that can be a hard jump from people coming from kind of a science background, where you may be thinking of data as I have just observed some sort of experiment. Whereas kind of whenever you're building something that interacts with the real world, you are now also controlling what your future data looks like based on kind of behavior of your algorithm for the current round of data.
Right. So given that you probably can't avoid feedback loops, the thing you need to then really invest in is the human in the loop. And so a lot of people like to focus on automating things, which I find weird. If you can decrease the amount of human involvement by like 90%, you've got almost all of the economic upside of automating it completely, but you still have the room to put human circuit breakers in place. You need these appeals processes, you need the monitoring, you need humans involved to kind of go, hey, that's weird. I don't think that's what we want. Okay. Yes, Rachel.
And I just want to note about that, those humans do need to be integrated well with kind of product and engineering. And so one issue that comes up is that in many companies, I think that ends up kind of being underneath trust and safety, handles a lot of sort of issues with how things can go wrong or how your platform can be abused. And often trust and safety is pretty siloed away from product and eng, which actually kind of has the control over these decisions that really end up influencing them. And so
the engineers probably consider them to be pretty annoying a lot of the time, how they get in the way of them getting software out the door.
Yeah, but like the more integration you can have between those, I think it's helpful for the kind of the people building the product to see what is going wrong and what can go wrong.
If the engineers are actually on top of that, they're actually seeing these things happening, that it's not some kind of abstract problem anymore. So, at this point, now that we've got to the end of chapter 2, you actually know a lot more than most people about deep learning, and actually about some pretty important foundations of machine learning more generally and of data products more generally. So now's a great time to think about writing. Sometimes we have a formatted text that doesn't quite format correctly in Jupyter Notebook, by the way. It only formats correctly in the book, so that's what it means when you see this kind of pre-formatted text. So the idea here is to think about starting writing at this point before you go too much further. Rachel.
Thanks.
Oh, there's a question.
Oh, okay, let's get the question.
Yeah, somebody in the chat also just said
I assume there are
it's
fast AI type ways
too
of keeping
fast.
a nightly
So I'm
updated
gonna put
transfer
it.
learning setup. Could there be one of the fast AI version 4 notebooks have an example of the nightly transfer learning training, like the previous person asked? I would be interested in knowing how to do that most effectively with fast AI.
Sure. So I guess my view is there's nothing fast AI specific about that at all. So I actually suggest you read Emmanuel's book, that book I showed you, to understand the kind of the ideas. And if people are interested in this, I can also point you at some academic research about this as well. There's not as much as there should be, but there is some good work in this area. Okay, so the reason we mentioned writing at this point in our journey is because things are going to start to get more and more heavy, more and more complicated, and a really good way to make sure that you're on top of it is to try to write down what you've learned. So sorry, I wasn't sharing the right part of the screen before, but this is what I was describing in terms of the pre-formatted text, which doesn't look correct. Rachel actually has this great article that you should check out, which is Why You Should Blog. I will say it's sort of her saying, because I have it in front of me and she doesn't, weird as it is. So Rachel says that the top advice she would give her younger self is to start blogging sooner. So Rachel has a math PhD, and this kind of idea of like blogging was not exactly something I think they had a lot of in the PhD program. But actually it's a really great way of finding jobs. In fact, most of my students who have got the best jobs are students that have good blog posts. The thing I really love is that it helps you learn. By writing down, it kind of synthesizes your ideas. There's lots of reasons to blog. So there's actually something really cool I want to show you. Yep.
I was also just going to note, I have a second post called Advice for Better blog post that's a little bit more advanced, which I'll post a link to as well. And that talks about some common pitfalls that I've seen in many blog posts and kind of the importance of putting the time in to do it well and some things to think about. So I'll share that post as well.
Thanks, Rachel. So one reason that sometimes people don't blog is because it's kind of annoying to figure out how to, particularly because I think the thing that a lot of you will want to blog about is cool stuff that you're building in Jupyter Notebooks. So we've actually teamed up with a guy called Hamel Hussain and with GitHub to create this free product, as usual with FastAI, no ads, no anything, called Fast Pages, where you can actually blog with Jupyter Notebooks. And so you can go to Fast Pages and see for yourself how to do it, but the basic idea is that like you literally click one button, it sets up a blog for you, and then you dump your notebooks into a folder called _notebooks, and they get turned into blog posts. It's basically like magic, and Hamel's done this amazing job of this. And so this means that you can create blog posts where you've got charts and tables and images, where they're all actually the output of Jupyter Notebook, along with all the markdown formatted text, headings, and so forth, and hyperlinks and the whole thing. So this is a great way to start writing.
What was that?
I was just said, where did you go? No. So he was just talking about blog posts. Essentially, I think our stream is the blog post that we're doing about the course.
Yeah.
About what you're learning about here. So something that Rachel and I both feel strongly about when it comes to blogging is this, which is don't try to think about the absolute most advanced thing you know and try to write a blog post that would impress Jeff Hinton, right? Because most people are not Jeff Hinton. So like A, you probably won't do a good job because you're trying to like blog for somebody who's got more expertise than you. And B, you've got a small audience now, right? Actually, there's far more people that are not very familiar with deep learning than people who are. So try to think, and you really understand what it was like 6 months ago to be you, because you were there 6 months ago. So try and write something which the 6 months ago version of you would have been like super interesting, full of little tidbits you would have loved, that would have delighted you. That 6 months ago version of you. Okay, so once again, don't move on until you've had a go at the questionnaire to make sure that you understand the key things we think that you need to understand. Have a think about these further research questions as well, because they might help you to engage more closely with the material. So let's have a break, and we'll come back in 5 minutes' time.
How far ahead are
So
we
welcome back, everybody.
In this video?
This is a interesting moment in the course because we're kind of jumping from
halfway.
About
part of
halfway.
the course, which is very heavily around kind of the structure of like what are we trying to do with machine learning, and what are the kind of the pieces, and what do we need to know to make everything kind of work together. There was a bit of code, but not masses. There was basically no math. We kind of wanted to put that at the start for everybody who's not, who's kind of wanting an understanding of these issues without necessarily wanting to kind of dive deep into the code and the math themselves. And now we're getting into the diving deep part. If you're not interested in that diving deep yourself, you might want to skip to the next lesson about ethics, where we, is kind of, that rounds out the kind of, slightly less technical material. So what we're going to look at here is we're going to look at what we think of as kind of a toy problem. But just a few years ago, it was considered a pretty challenging problem.
Hey, Nick,
the problem is recognizing handwritten digits.
Question. Can you pause it?
Yep.
What if we, this is really long. What if we break it up because it doesn't really matter. We've been watching for an hour already. Mm-hmm. What if we break it up? Also, I think he's starting a new topic, it looks like, to me. We don't really need to keep it on the lesson basis, right?
Yeah, he's doing chapter 4 now.
Right. So what if we wrap up the watching stream with this, and then on Friday we build, because we still, we want to be both for the dog breed classifier and for the desktop background classifier, we could build out this little widget thingy that he just described. I think that would be interesting to do, and I think it would be even cool if we did it twice for both of the classifiers that we built, just to train it, because anyways, I already forgot most of the stuff we did last time, so
sure.
Going over it again is going to be helpful.
Sure. Do you wanna share your screen and take over?
Oh, do you want to do it now? No, I just I am not prepared for this.
Got it. So you want to kind of end the stream here?
I was thinking, yeah, because we're doing Fridays to build the stuff, right? So I was thinking, we could, what we did last time, we could go over the notebook that he talked about and just discuss what were the different parts, and then actually build it out next time. That's my suggestion.
Okay. And then what do you want to do with the other half of this video?
afterwards, like next Monday, we continue here.
Got it. Okay. Yeah, that sounds
Because
good
it's
with
not, I mean, 2 hours is pretty long to just watch something for me. And if there's like a logical stop here, it makes sense.
me. Okay. Oops. Let's just do that. All right, sounds good.
So do you want to open up the notebook and we look over just to recap the stuff that you talked about at hand of looking at the code? That would be helpful for me.
Sure. Which of the hold on, now I gotta find
Well, I can do it. I already got it open, I think.
Okay,
It's just
so you can,
the
go ahead, share your screen.
Yeah, it's just the bottom of the messy one. Wait, no, this is not it. Okay, where did I got it? Nope. Nope. Runtime disconnected. Okay. We probably don't really need it because if I try running things, we're in error land. So, okay. All right. Where were we? And sidebar from data to data loaders. This is probably stuff we did. Blocks, yeah, I think we talked about this last time. And then resize. Data augmentation. I think this is what he started off the lecture with, right? We're talking.
Yep.
Was talking about data augmentation. Okay.
This
So
was
what's
like a third of the way in, or like a quarter of the way in, but yeah.
He did this before.
He was talking more about like the stretching first, and then we did the scroll down a little bit, the random resize, and then he went into the augmentation.
Resize crop.
Yeah, random resize crop. So
Okay,
that's kind of
so
like
this
where
is
we
not yet.
well, that's
Isn't
kind
that
of where
also-
we started, the random resize crop.
I
Let's
see.
just
Okay, that's not. Sorry, I'm trying to figure out from data to data loaders. Okay, this is where this is in. But that would also be data augmentation, right? Is that not data augmentation?
No, the augmentation was like shifting the perspective and
Cropping isn't?
no, because it's still the same image, just a different part of it. The augmentation was the entire
Okay.
image, but like changing, like warping the image.
Okay, makes sense. And would you like consider squishing data augmentation? Because that changes the image actually.
Would I personally, or would
All right.
I
Yes,
personally
please.
probably? But does that agree with what we saw so far? I don't think so.
Okay.
Yeah.
So
Again, like the augmentation was like changing the contrast and changing the perspective and like warping the image. It was like very weird.
Okay, so look, we still have the OS systems in here from the thing.
Yeah.
So what I remember from this lecture now is like we have this .new, which is something that we can, like it's a method that we can call on a data batch. Is that a data batch? Data loader, sorry for scrolling. Data block, that's what it's called. Okay, so I'm making a data block, and then I can make a new data block out of that same data block by calling a .new method on it, which is gonna, and I don't have to remake the data loader, but I can just do that and apply different types of resizing, or I think the augmentation probably also gets called on that, right?
The augmentation was called on it was a batch augmentation. So it was, it's probably in the example of the augmentation if you scroll down.
Okay, and so he talked about this, that it like both squishing, stretching, cutting stuff off, or padding it with zeros, making it black around, is problematic because you either create data or you lose some data. Right? That makes sense. I remember that. And I'm just trying to recap everything that I heard and jump in whenever
Yep.
there's something that doesn't make sense. Okay, and then he said that a common way of using this was common.
Oh, we did do
whatever.
this last time. We did do random resize crop.
Yeah, true.
I do remember
on
that,
there. Random resize crop is a common one. And that just takes, okay, so I think this one is cool. If I understand it correctly, it like, I picture it like this. I have this one image that's a certain size, and for the first epoch, it takes a window of that image and uses it for training, I guess. And then in the next epoch, it takes a different cut of the same image.
Yep.
So we always have the same label because it's the same image, but it's different parts of it for each training epoch.
Yep. Yeah, and the min scale .3, like 0.3, was just to make sure that at least 30% of the original image was included in that crop.
Cool. Nice. Did he say why 0.3? Is there any, or is that one of the magical numbers you just get the feel for when you've done it for a while?
Yeah, I think it's one of those magical numbers.
Great. Oops.
No, I'm sure there's a paper. Multiple.
A magical
on
paper.
Yeah, more magic.
All right, good. 0.3. We shall remember. Unique true to have the same image repeated with different versions of this random recess. This is a specific Oh, look at that. This is a specific example of a more general technique called data augmentation. Bam. So the random resize crop is data augmentation. After
There you go.
Okay, cool. So then we looked a little more at data augmentation, and once we're using here, standard set of augmentation, we found worked pretty well. Aug transforms function. First, we make it the same size, and then we can apply them on a batch. Yes. And aug transform does what? It does all the things?
I don't remember. What?
No, I remember. He was like, he was actually scanning through these. I probably can't do that now because none of this is loaded, but
it's also, that's, I mean,
there's like some way that you can, what was the shortcut to get the?
shift tab, like shift tab.
Shift tab. Okay, it's not working for me, which is probably because we don't have a batch, right? Like the bears is not loaded. Oh yeah, now it's bears again. So we didn't do that last time.
Yeah. Do you want to change the OS systems?
No, because we don't have the OS systems loaded. There's this.
Oh, that's right. In the beginning. Yep.
Yeah.
We gotta refresh our API keys.
Okay. Look, I can hover on it. Nice. So aug transform. So he's using mult, whatever that is. But okay, and then there's different, you can just set different keyword arguments to it. Flip it vertically, rotate, zoom in.
Zoom, warp, we'll change the lighting.
Lots of stuff. Cool. So I guess he's just doing one thing here, but you could do a couple of different,
Sure.
You could apply a couple of transformations. And conceptually, this does the same thing again. Like the point is that I get images that have the correct label, but I get them in different versions, kind of like, so I just get more data out of one image. I can make a lot of images that are all labeled correctly and look slightly different, but still, I guess, generalize a bit over the thing that's actually displayed on the image.
Mm-hmm.
So, yeah,
sounds right.
Sounds right. Good. Okay, and then, all right. So this is that data augment. I want to try this on on either the dogs or the desktop backgrounds.
Mm-hmm.
I wonder whether it's interesting for the desktop backgrounds because they're like images, right? They're not. It's not about. What? What are you laughing about?
But I mean, because they're just images.
No, but it's not about.
But they're all images.
It's not about recognizing what's on the image. I mean, I guess it is. It's not about identifying something on the image. It's about identifying some style in the image. You don't want to talk about this, huh? Too personal.
It's
Windows backgrounds.
Yes, however, What were we doing? Oh, we trained the model last time to say anything with a penguin was a Linux background.
Did it end up like that? Didn't you? I think
Yeah. Because we had, and then I thought it was gonna be. Yeah, no, it was not a very accurate model whatsoever. we were
despite the 450 input images. that we
right,
had.
the massive data set of input images and clean and unbiased and. No, we were trying to do for Linux. We were like anything with a penguin, and that's what it ended up being because we labeled the ones that did have penguins as Linux wallpapers.
Did we have like real picture penguins that we labeled as
Yeah,
Linux
we had this
backgrounds?
one that was like a beautiful National Geographic shot of penguins, and we labeled it as. And actually, we didn't label that one. We tested it, and then that one was a Linux
Okay, yeah,
background, which I thought was kind of surprising.
Yeah. Okay.
Okay, so what are we doing now? What are you
We're moving on.
moving on? Okay.
Training your model and using it to clean your data. Okay. What did he talk about here? We don't have a lot of data for a problem.
So are you going to run anything on this or?
No, I can't run anything because I'd have to fix everything further up.
Right.
Should I do that? That like sounds messy considering that, the data is not there and we don't have the API key to download it again. Like it created a file system and started doing this when we ran it before, but it didn't download anything because our API keys are, I'm pretty sure it's because our API keys are just.
Yeah, it's been like 2 weeks since we got it.
Yeah.
So that makes sense.
So we'd have to set up this API key again so we can download the.
Mm-hmm.
And it really seems that this file system is not persistent for some reason.
Did you change anything while we were doing the because where's everything else? Oh, like the bin, dev folders, home folders. Is that like in another?
No, I think I'm just maybe one level down or something.
Oh, okay.
Oops.
Whatever, it's fine.
Yeah, I'm just here.
Okay.
So I was inside of content, I think.
Yep.
And then drive is mounted, but it's not. I don't know. Like this data is here. I think our classifier is here. Yeah, there it is. That's the pickled classifier that we saved. So at least we have that still. So I guess I could load this one back in, right?
You try it.
I mean, it should work. Cleaner. Oh yeah, we did that last time. I talked about this again. This is really, it's pretty cool, all this stuff that's built in here. Let's predict. Okay. Turning your model into an online application. So this is what we're going to do on Friday.
Yeah.
And we should be able to load our.
There you go.
Oh, it's classic. We exported it
export.
Here. So starting from here, we should be able to do this again. Path, ls, export.
So
now we want to load it. Okay, so I gotta get the path. Path is base path. Where do we define base path?
I think we defined it up as the current working directory, which was content.
So let me fix that. Oops. So we need from path and then say can do that. Oops. I think that should work. And then path.ls. Nothing in there because we want to go path equals this plus. And we want to go into. So we're in content, right? No, here's the Colab notebook. So maybe we're in. I guess I should just print it out. So let's see where we are.
Yeah, you're
Slash
in content.
Okay, so then I gotta go. We saved it in content drive, my drive, data.
Yep. You have that line somewhere above too saved. So
Yeah, whatever.
I think that's what you did set. Anyway, whatever. You're currently
Should-
you're in content, so I don't think you need that first one, right?
Oh, you're right. Thanks. Drive, my drive, data, and then it should
Cool.
find it. There it is. Okay, perfect. So that's our pickle. Copy, export, pickle. So you wanna use this bash to export. It's called export.pickle. That's not what ours is called. It's copying it to drive.
Just if you
Whatever can do. I need the whole path then. I don't know why he's copying that, but
you may have to just escape that space, but in my drive.
yeah, right. Can do that. I think that works too, right?
I don't know. I've never seen that before, but
Cannot create regular file. Operation not supported. Okay, it doesn't matter. We can just load it from that path. We can just load it from the path.
Yeah.
Okay, so load learner, path, export pickle.
just change the
yeah, right. Thanks. OS classifier. Okay.
cool.
Where are we? Here. One gone away. File system. I don't like you. Okay. When we're doing inference, we're generally just getting predictions for one image at a time. To do this, pass a file name to predict. If we had a file, we could do that. Hello, file system. I think we do have some wallpapers in here, right? For some reason.
Yeah.
15.jpg, that's something we can play around with.
Yeah, I wonder where the other wallpapers went, because we did download them, and then we
Content,
changed the names, like
drive.
Windows or .Mac or something. I forgot how we did it.
Uh-huh. Does that work? Mac.
Okay.
So this is classifying it, this one as a Mac desktop background. Okay. This is returned, sorry. This is returned three things. The predicted category of the same format you originally provided. In this case, that's a string. We said predicted as a string. The index of the predicted category. That's here. And the probabilities of each category. That's here. The last two are based on the order of categories in the vocab of the data loaders. It's the stored list of all possible categories. At inference time, you can access the data loaders as an attribute of the learner. Linux, Mac, Windows. Those are the three. What's it called? Categories. Okay, we can see here that if we index into the vocab with the integer returned by predict, we can get back grizzly as expected. So it's just saying you can do this to get back Mac. Yeah. Also note that if we index into the list of probabilities, we see nearly one probability that it's a grizzly. Ours wasn't that great. Vocab. So that would be 0.7. It's like 70% sure, 76% sure that it's a Mac background. Not bad. Okay, cool. So, and then, so we got our pickle thing, so that means we can, next time we can actually do this whole thing, practically go through all these upload buttons and make an app.
Yep.
I didn't completely understand what was this.
I don't know. You know what we should do next time for the app, and maybe we can connect from now until Thursday about this. But so do you want to create the app within Jupyter Notebook, or do you want to have like an actual app?
So I mean, that's what he does, right? Like, I think we should go through the process that he does here. It seems pretty cool that you can just do it with this widgets and then publish it.
Yeah.
And then you have this actual app that you can run online.
Mm-hmm. Okay.
Sure, we could build a web app somehow, but I mean, it's cool that it's supposedly so simple, right?
Yeah. All right, let's do it.
Yeah. So I'm just gonna high level go over this to recap it for myself, and then next time let's build it. So what I remember about this one is that there's these widgets that they built, I think, and I think they built this voila thing too. And the widgets allow us to have upload buttons. And then from the upload button, we can pick the data out. Click on the upload button, so we fake it. For the book. Okay, so this is faked. But otherwise it works, and then I think you have to do 0 or like get the last item, and then pipe the binary blob into the image library. Then you get the image. And then you can call this prediction on it to get the prediction. And then you can make label widgets that then display something. And then I think he's doing this V. What was the V? There it is, VBox. And pass in an upload button, a run button, output, place for where the image gets rendered, and the prediction. Pretty cool. A mini app. His eyes look weird. What's going on with his eyes?
I think it's just super. I think some pixels are missing. I think that's it, and just very shadowy.
That's a scary bear, man. Dead. Probability dead. Okay. And then
all right, so let's. Yeah.
Sorry, I'm nearly done. Then this is how you can run it inside of the notebook. But then the step to putting it on a separate thing where people can only do this is this using voila. Jupyter server extension says installing those things. Do not window, yes. And then you can deploy it by putting it into a GitHub repository. Paste the URL binder, right? Cool. Right, that's a lot of text down here, but I'm happy. How to avoid disaster. Maybe you should read that.
Let's.
I think this is about bias, right? Is it?
Yeah. So for Friday, let's button this up a bit.
Yeah. Okay.
So do you want to wrap up? Whoops. Do you want to wrap up this stream because we're not really?
Sure, I'm good. Yeah, I just wanted to go over everything that I read from what he was talking about in the.
Cool. All right, sweet. So I'm gonna stop this stream and then we'll pick this up on Friday again. All right, Thursday. Okay. This week it's Thursday.
Thursday.
We're starting Thursdays
Monday,
again.
Thursday.
Yes. All right. Well, thank you to all our viewers and everybody in the chat. All right, we'll see you Thursday.
Okay.
Peace.